Well, Phil, I know you're interested in online learning, and I want to show you how I tutor students online. I think you'll really like it. I use a website called Conceptboard. I've been using it since at least 2013, maybe even before that. I cannot quite remember, but I've tutored students in Japan, in Vietnam, the Philippines, um, as well as around the United States, and just a little bit down the street from me. If you're in the middle of a pandemic and you can't go around to meet people, it doesn't matter if they're near or they're far. So, are you interested in learning about it? Okay. Well, what I'll do is I'm gonna give you a little demonstration lesson here. And hopefully you'll get a sense of what you can do with concept board. It's really a pretty nice tool to use. I've found it works really well for me, and I keep learning more about it as I go along. But let me get right into a little lesson. I want to teach you how to simplify a radical. For instance, the square root of 12. And just the way you simplify a fraction, like if you had the fraction 7/14, you can simplify it to another number. You can simplify it to 1/2. They're exactly the same thing. 1/2 and 7/14 are just two ways of writing the exact same number. So we're going to find another way of writing the square root of 12 that'll be slightly simpler. Now, to do that, I'm going to have to teach you some things that, even though I know you're not only a high school graduate, but also a college graduate, and on top of that, a self taught man, that you know a lot of mathematics, but I'm going to venture to guess that you might learn some things today that you don't know about math. I hope you do, at least, and I hope you find it interesting. Okay, so we're going to start out with something very basic called order of operations. And I know you learned the order of operations in school, but when people are taught it nowadays, the general way that you hear people learn is to use an acronym, and the acronym is PEMDAS. And P stands for parentheses, E stands for exponents, M for multiplication, D for division, A for addition, and S for subtraction. And so, what they teach people then is that you should go from left to right. You do everything that's in parentheses, and then you do your exponents and your multiplication, your division, addition, and subtraction. So, I'm going to tell you that I don't like PEMDAS, and there's a couple of reasons for it. One of the reasons is that parentheses are not an operation. So even though parentheses are very important, they're called a grouping symbol. So the first thing I do when I teach students order of operations is I remove the parentheses, and we'll get to that later because that's simply a different kind of thing. It's not an operation as the way exponents, multiplication, division, addition, and subtraction are. Does that all make sense so far? Okay, so now I might ask you a question. Could you do this problem using correct order of operations? 10 minus 1 plus 8. How would you do that to get the correct answer using order of operations? Okay. Well, that is exactly one of the reasons that I don't like this way of teaching it, because that is the wrong way to do it. It turns out that you're supposed to do the subtraction first and then the addition. And so rather than using PEMDAS, I'm going to show you a different way that will give you the correct answer. So instead, I'm going to write it this way. So instead of writing it the way it's generally taught, I'm going to write it this way. And let me get rid of that other E there that is really not what we want to be there. Okay, so this is how I like to think of it, because now we have three levels of operations. We've got the addition and subtraction. We've got the multiplication and division. And we've got the exponents up here. Now, the rule is you do the highest level operations first, then go down to the next level, and then the next level. But if two operations are on the same level, you do them from left to right as if you were doing the way you read from left to right, as long as you read in English. If you read in Arabic or Hebrew, then you have to do it backwards from what you're used to. So now, because of that, we're going to do the subtraction first and the addition second. And if you put this into a calculator will automatically do operations in the correct order. So first we're going to do this, and we'll get 9. And then afterwards we'll do the 8. You add the 8, we get 17. If we did what you originally suggested, do the addition first, which is the way people teach it by saying go from left to right, then they would do the 1 plus 8 first and get 9. And then you'd have to do the 10 minus 9 and you'd get 1. And as I showed you, if you do this on any calculator, 10 minus 1 plus 8, type it in that exact order, you will never get 1, you will get 17. So one of the reasons I've chosen to teach order of operations this way is because of that. Now, the operations that are on the same level have a relationship to each other. They're called opposite operations or inverse operations. Addition and subtraction are inverses, multiplication and division. What about poor exponents? Why exponents have their own operation to go with them? And it turns out the reason or do you have an idea why, by the way? Well, the reason is when people first learn order of operations, they're generally in about 5th grade. And if you're in 5th grade, you may have just seen what an exponent is, but you don't have any idea of another operation. And that other operation is the opposite operation to exponents. And that operation, do you want to take a guess? Well, not you're warm. It's because there's more than just square roots. There's all different kinds of roots. So it's actually just roots because you can have square roots. So now a 5th grader would have no idea about that, but now we can include this other operation, make this look much more symmetrical, and will make a lot more sense. Okay? So this is how you're going to do order of operations. But there are other uses for this. And one way, I'm just going to show you very quickly because I don't want to get off on too much of a tangent, but lots of times students might say, I've learned in algebra that I can multiply x to the 5th time. Well, actually, I won't, since someone who watches this may not be familiar with algebra, I'm going to do this with numbers without variables for the time being. So I'm going to say maybe you might want to multiply 3 to the 5th by 3 to the 2nd. How do you do that? How can you simplify that? And here's where this little symbol of operations will help you with that answer. If what we did was a multiplication between the two exponent or the two bases, you look for multiplication here and you say, what's immediately below multiplication? Well, the answer is addition. What that tells you then is we're going to add the exponents so that you end up with this being equal to 3 to the 5 plus 2, or 3 to the 7th power. If instead I said, okay, instead of multiplying those two, what would happen if we decided to divide those two? What would that be equal to? Well, then you say, well, let's find division here. And what's below division? Subtraction. So we're going to subtract the exponents 3 and 2, and we'll get, 5 and 2, and we'll get 3 to the 3rd power. Now, let's try one more. Actually, we're going to try a few more. What if we did 3 to the 5th plus 3 to the 2nd? Well, we look for addition down here and say, what's underneath the addition? Well, guess what? There's nothing you can do with that. So this is just a very nice tool for learning how to do that. But let's do another one that's a little bit different than this. We're going to go 3 to the 5th, and now we're going to raise that. We're going to do an exponent of the exponent. So we're going to say raised to the 4th power. So we're doing an exponent of the exponent. So we say, okay, where's the exponent? Right here. What's below it? So this is going to equal, we're going to multiply the exponents, and we're going to get 3 to the 20th power. And that's exactly the way it works. One last thing, and all these things I've shown you are often taught in school, but now I'm going to do something that is not often taught in school. In fact, I've never seen it. I'm not saying I certainly didn't invent this. I'm sure other people have said this before, but now we're going to introduce roots into this problem. So let's say we had 3 to the 24th power. And I say, well, what is the 8th root of 3 to the 24th power? Well, the operation here is a root. So we look down here and say, what's below roots? So the answer to this is 3. We're going to take the 3, but with the exponent of 24, we're going to divide it by the 8, and we'll get 3.